curves, our first topic here in finals. So horizontal curves is needed in designing a road. So ini-introduce ang horizontal curve for safety purposes and syempre to avoid mga inaccessible uh, areas na di kayang daanan ng roadway na i-design natin. So for safety reasons, we avoid designing roadway that is straight for too long. So mga 200 meters, 300 meters, 400 meters, at least there is a horizontal curve on that roadway. So isang example dito. For safety purposes, yun nga, kung in-straight lang yung road dyan, napaka-steep ng slope ng roadway. And hindi yan safe para sa magdadrive. So dito, may mga curves dito na introduce para ma-lessen yung slope sa ating roadway. So, sa pagdi-design ng roadway, sa horizontal curve, so madami tayong kino-consider dyan. So, una, yung traverse na nakuha dun sa survey. So, yung mga traverse line, yun yung pagbabasihan nung kung saan natin ipi-place yung ating horizontal curve. So, another factor din is yung slope ng lupa. But here sa fundamentals of surveying, we will just focus on understanding the parts of a horizontal curve rather than designing of a horizontal of a roadway which involves horizontal curve. So dito sa lesson na to, we will just try to analyze what are the parts of a horizontal curve. Kasi sa transportation engineering, nandun na yung design part ng roadway. So dito, this is just an introductory lesson with regards to the transportation planning. So, kaya sa mga major subjects nyo na yun, may encounter ang mas in-depth discussion o mas malalim na topic with regards to designing a roadway. So dito sa plano na to, we have 3 horizontal curves here. Una, nandito, kasi nandito yung point of intersection. There's another point of intersection here, so there is another horizontal curve here. And dito sa part na to, this is just PI. So, isa pang horizontal curve. So, that is possible that sa isang liko, madaming horizontal curve na present dun sa part na yon. So, depende yan sa design, depende sa terrain ng lugar, depende sa geographical features ng area na didesign na natin ng road. So, what are the horizontal curves? So, ito ngayon yung mga horizontal curves natin. First one is the simple curve, then the compound curve, reverse curve, and the spiral curve. So mag-start tayo sa pinaka-basic na component ng isang horizontal curve, which is the simple curve. So from the word itself, it is simple. So a simple curve is derived from a sector of a circle. So this is a sector of a circle. Okay? So this is sector of a circle, and from that, lahat ng computation natin, madiderive natin galing dyan. So, what are the parts of a simple curve? First one is we have PC, or the point of curvature. So this is the starting point of a simple curve. And we have PT, or the point of tangency, which is the end point of the simple curve. Now at PC and PT, we have tangent lines from that point, which is, we have a line that is tangent to that. We call that the back tangent, which is this one. The forward tangent, yun naman sa part ng PT. Now, the point of intersection of these tangents is called PI, or point of intersection. And the angle formed by this point by the intersection of the tangents is called the angle of intersection, which is I. So ang angle of intersection I is also equivalent to the central angle of the uh, of the of the simple curve. So other parts are, we have tangent nga, T. So the distance from PC to PI has the same distance from PI to PT. So that's tangent also. So we also have a chord, length of chord, L. This is a line measured from PC to PT, which is this one, L. Meron din tayong tinatawag na LC, or length of curve, or the pathway of the road itself. So yung curve mismo, yung arc mismo ng ating simple curve. So we have a external distance, or the distance from the point of intersection to the midpoint of the arc of the simple curve. Also have a middle ordinate measured from the midpoint of the curve to the midpoint, or halfway, the distance of the chord of the simple curve. So we have also the radius here, okay, and this is the center of the simple curve. Now we also have a offset distance. So at any point of the curve, there is an equivalent offset distance, which is measured from the tangent, and then perpendicular to it, measure a distance from the tangent line to that point we are determining. So that's what you call the offset distance, x. And it also have a corresponding equivalent angle that is measured from the tangent to that point. So we assign that as theta, or the offset angle. So theta is the offset angle subtended at PC between PI and any point of the curve. Now, so if the point we determine is at PT, the equivalent offset angle is this one. Okay. By the way, the offset angle of a point when measured, the equivalent central angle of an offset angle is equivalent to twice its value on the central angle. So kung theta dito sa offset angle ng point na yun, i-multiply lang natin yun ng 2. Yun yung equivalent central angle niya dito sa center ng ating simple curve. Kaya, if we are measuring the offset distance at point where located at PT, so ang sukat ng angle na yon ay from there to here. So if this is the central angle of the curve, which it ends at PT, from PC to PT. Ibig sabihin, kalahati nitong I na to, yun din yung equivalent nitong angle na to. So, it is I over 2. So, wait lang. Okay. So, what are the formulas that we will use here in simple curve? So, mga formula na yan, madiderive lang naman yan galing dito sa mga right triangle na mafo-form natin dito sa simple curve. We have this triangle. Okay, we can use that. And lahat ng variables doon, pwede nating i-derive doon. At meron din dito na triangle na to. Meron din dito. So, ito yung right triangle niya. So, okay lang ba sa inyong class na hindi ko na i-derive yung equation kasi matatagalan tayo? Or i-derive pa? So, itong mga formulas. Itong mga formulas. T equals to R tangent I over 2. E equals to R secant I over 2 minus R. We have M times R times minus R cosine I over 2. We have L 2R sine I over 2. And LC pi RI over 180. So, yan mga formulas, class. So, ano, i-derive pa natin, di na?
Kahit wag na po, sir.
Okay, kahit wag na. Pero yun nga, lahat ng formula na lang naman yan, galing naman lang yan sa trigonometric functions that is used in a right triangle. So, sine, cosine. So, just find it here. And kung may time kayo, you can derive it on your own. So, just use this right triangle. Also use this right triangle. From that, you can derive those formulas for E, M, L, tangent, and so on. So, for the length of curve, this is just a formula for length of arc of a sector. Okay, this is length of arc. So, lahat na yan, if you can memorize it, memorize it. So, one factor in how sharp a curve is on a horizontal curve is by determining its degree of curve. So, the smaller the degree of curve, the flatter is the curve, and vice versa. So, the sharpness of simple curve is also determined by its radius. Large radius are flat, whereas small radius are sharp. So, smaller radius on a horizontal curve, on a simple curve, it means it has a sharper curve. Or kung liliko ka, masyadong sharp yung curve na lilikuan mo. So, how do we determine the degree of curve? We have two methods, or we have two bases in determining the degree of curve. The first one is by arc basis. Second is through chord basis. So in arc basis, we have one station. Then we will measure that equivalent central angle of that sector. Okay, so if we have given one station distance, which is measured along the arc, okay, we will find the equivalent central angle of that, or the degree of curve. So here sa Philippines, we use one station equivalent to 20 meters. So for every 20 meters, we have one station. So we take the ratio of one station over the equivalent central angle, which is D, is equals to, ipoproportion natin siya sa whole circle, which is, kung yung 20 meters mo o yung length ng one station mo along its length is this arc. So, kung sa buong circle, yung circumference ng circle, which is 2 pi r. Now, the equivalent central angle of that is, of course, the whole angle, which is 360 degrees, so one revolution. So, substitute now, one station is 20 meters divided by d. So, it's equals to 2 pi r over 360. Now, to determine d, cross-multiply natin. We will have 20 times 360 equals to 2 pi r d. So, divide both sides by 2 pi r. We have 20 times 360 over 2 pi r equals d. Now, let's evaluate 20 times 360 over 2 pi. When we solve this, that is equivalent to 1145.916 over r. That is the solution in determining the degree of curve basing on the radius of the curve. So just substitute the radius and on this value, on this equation, so that you will have the degree of curve. So for chord basis, one station is measured along its chord. So yung 20 meters nandito. Okay? So ito yung 20 meters natin. So, makaka-form tayo ng right triangles here. Ito, yan. So, ito, half nung degree of curve, then r. So, take the trigonometric function of sine. So, sine d over 2, take the half of the station because kalahati lang naman. So, 10 over the hypotenuse, which is r. So, sine d over 2 equals to 10 over r. So, kung hanapin yung degree of curve, take the arc sine of 10 over r, then multiply it by 2 para mahiwalay yung d. So, this is the solution in determining the degree of curve by chord basis. So, example. Two tangents of a simple curve have azimuth of 120 degrees and 156 degrees 30 minutes, respectively, with a radius of 400 meters. Determine the following. First, degree of curve using arc basis, then degree of curve through chord basis, tangent distance, external distance, middle ordinate, length of long chord, and length of curve. So, before we start, tanong ko lang class, clear naman ba ang sound ko sa inyo? Clear naman akong naririnig?
Opo.
Yes po. Opo.
Clear naman, wala namang background noises. Wala naman kayong naririnig na nagbe-video eh.
Wala naman, sir.
Wala
Wala
sir.
naman. Kasi sa kapitbahay. Okay. Sige, let's answer that problem. So we have here two tangents. So usually sa mga problem na ma-encounter natin sa horizontal curve is that there's no given figure. So kayo mismo ang magdodrawing ng curve, ng horizontal curve. So dapat alam natin kung paano siya i-drawing. So here, given daw yung tangents. Okay? Tangents of a simple curve. Ito yung given. Yung kanilang azimuths. 120 and 156 degrees 30 minutes. So, kung given yung tangents, yung azimuth ng tangents, so yun agad ang magiging basis natin. So, yung starting point daw, 120 degrees. So, first, measure an azimuth from the south of 120 degrees. So, ito yon. Then, draw a line na magsisilbing tangent. So, let's say ito na yun. That's from point PC to point PI. Then after that, draw another line which is measured from the azimuth 156 degrees, 30 minutes. So again, from south, measure 156. So ito na yun. Then draw another line. Ito na yun. PI to PT. So nasa screen nyo class yung yung drawing?
Yes po.
Yung yes.
Opo,
Okay.
sir.
So, given yung radius, which is 400 meters. Now, base pa lang dun sa mga given na direction ng tangents, from that, we can compute the angle of intersection of the curve. So, syempre kung saan class yung opening ng tangents, dun nyo din i-drawing yung curve. So, kaya dito yung tangents, itong color green, then dun nyo lagay yung curve ng ating simple curve. Tapos, mag-drawing kayo ng perpendicular line galing dun sa tangent para ma-close nyo yung simple curve natin. And yan na yung final drawing. Now, balik tayo dito. Yung kanyang angle of intersection, para may measure to, kukunin natin yung azimuth ng previous, which is 120 degrees. Kung i-extend natin siya dito, ito yan, di ba? 120 degrees. So therefore, if I subtract this azimuth, 156 degrees, 30 minutes, to the azimuth of the back tangent, which is 120 degrees, ang matitirang angle ay eto. So, 156 degrees minus 120 degrees is equals to 36 degrees and
And
30 minutes.
30 minutes.
Okay. So, kung yan yung angle of intersection, yun din yung equivalent ay dito sa central angle natin. Okay? So, ano yung required? What is the degree of curve through arc basis and chord basis for A and B? So, hanapin na natin. For the degree of curve by arc basis, T is equals to, sa dinerive natin na equation, we have 1145.916 over R. So just substitute R, which is 400. So the degree of curve is 2.865 degrees. So pwede din siyang naka-degrees, minutes, seconds. So using chord basis, so dun sa dinerive natin equation kanina, we have 2 arc sine 10 over R. So T is equals to 2 arc sine of 10 over R, which is 400. So the degree of curve to arc basis is also, kapag kinumpute nyo yan, ang equivalent niyan ay 2.865 degrees. So parehas. But hindi sa lahat ng oras magkakaparehas yung degree of curve through arc basis and chord basis. So careful in following in following the instruction or what is required on the problem kung anong basis no pagdedetermine ng degree of curve. So kasi pwede yan maka-apekto sa computation nyo kung meron pang ibang unknown. So for the tangent distance has a formula of R tangent I over 2. So, substitute R, 400, then tangent of I over 2. So, ang I over 2 pala, divide natin yung 36 degrees, 30 minutes, divide sa 2, ang equivalent niyan ay 18 degrees, 15 minutes. Okay, kaya T is equals to 131.9 meters. Okay? So, ganun lang. Direct substitution dun sa formula. External distance. External distance, E is equals to R secant I over 2 minus 1. So, E is equals to 400 times secant of 18 degrees, 15 minutes, minus 1. Okay? Substitute lang natin dun, class. Ang masosolve dyan ay 21.186 meters. Middle ordinate. Middle ordinate is R1 minus cosine I over 2. So, 400 times 1 minus cosine 18 degrees, 15 minutes. Okay? So, the middle ordinate is 20.12 meters. Length of long cord. Formula based then. Long cord, 2R sine I over 2. So, 2 times 400 times sine of 18 degrees, 15 minutes. So, the length of long cord is 250.531 meters. Okay. How about G? Length of curve. For the length of curve, length of arc, pi ri over 180. So, pi, r is 400. So, dito class, dun sa module nyo kasi na-substitute ko dun 18 degrees, 15 minutes. But, I tayo. I yung isa-substitute dyan, dapat dyan, 36 degrees, 30 minutes dapat. Ang I dito. Okay? So, dito kasi yung mga kinompute natin sa chord, tangent, external distance, middle ordinate, I over 2. So, 36 degrees, 30 minutes ang ilagay dapat dyan. Okay? Kaya, ang length of curve natin dyan ay 254.82.
54.82.
Okay. So correct. So, yan yung length of curve. Okay. So, ganyan ang pag-solve ng iba't ibang parts ng isang simple curve. Okay? Next. Sa ibang situation naman, ibang klaseng problem naman para sa simple curve. A simple curve given a middle ordinate of 4.5 and a deflection angle from PC to PT of 27 degrees. Determine the radius of the first curve. So, ganun class kung walang binigay na azimuth of the tangents. So, mag-drawing na lang kayo ng sample simple curve. And ganun yun yung basihan nyo o yun yung lagyan nyo ng mga given. So, sample dito, mag-drawing kayo ng simple curve. At doon nyo i-assign yung given natin ng 4.5, which is this one. Ito, middle ordinate. And the deflection angle ng PC to PT, which is 27 degrees. So, deflection angle from PC to PT. So, yung tinutukoy nyo na deflection angle is this one. So, yung angle subtended from the tangent to the line along the chord. Kung saan mag-e-end kasi siya dun sa PT. So, sabi ko kanina, kung ano yung deflection angle mo dito sa point na to, from the tangent to that point, twice ang value niyan pagdating sa kanyang central angle. So, kung i-extend natin yung point na yun at yung point na yun dito, so yung equivalent central angle nitong deflection angle na to ay madodoble. So, from 27 degrees multiplied by 2, that's equivalent to 54 degrees. So yun pala yung equivalent central angle ng ating curve. So that's 54 degrees, which is, that's also the eye. So ibig sabihin pares yan dito. So what is required here is to determine the radius. Since given is the middle ordinate, we can use the formula m equals to r1 minus cosine I over 2. Now, required yung r, so divide both sides by 1 minus cosine I over 2 to eliminate that quantity at the right hand side of the equation. Matira yung r. So, substitute the given 4.5, 1 minus cosine I over 2. Yan natin mo itong 54. Equivalent lang din naman sa 27 degrees. So, R. R is 41.287 meters. So, ganun lang. Okay. Next. Let's proceed. The line connecting the PC and PT of the simple curve is 120.4 meters. The radius is 213.6 meters. If the stationing of the PC is 9 plus 3, 6.1, determine the stationing of PT. So, yan. Walang ibinigay na direction ng mga tangents. So, just draw a simple curve sample. Then, dun nyo i-assign yung mga given natin na stationing, which is this one, 9 plus 3, 6.1. And we have a radius of 213.6. Another given is the line connecting PC and PT, or siya yung length of chord from PC to PT. That's the chord of a sector, which measures 120.4. So required is to determine the stationing of PT. So in determining the stationing of PT, all we need to do is add the stationing from PC to the length of curve. So sa pagdetermine kasi class ng stationing, lalo na along the curve, so ang required lagi doon na length is the length of arc of the horizontal curve. So yun yung kakailanganin natin sa pagdedetermine ng stationing ng any point on a highway. So yun yung nagmamatter doon, yung pathway mismo nung highway, which is itong curve mismo. Kaya when we determine the length of curve, just add that to the station of a PC. Now we can determine the stationing of PT. But before that, madami pa kasing unknown. The angle of intersection is unknown. So, di pa natin kayang direktang sagutan ang length of curve, knowing that we don't have angle of intersection yet. So, saan natin pwedeng i-derive yung angle of intersection? So, based on the given, we have length of chord and we have a radius. So, from the formula of the length of chord, we can substitute L and R from that formula so that we will be able to determine the unknown angle of intersection. So to determine I, so divide both sides by 2R para maging sine I over 2 na. Then take the arc sine of L over 2R, which is equals to I over 2, and multiply it by 2. Arc sine of L over 2R equals to I. So, substitute na. Substitute L. 120.4 to or 213.6. Ayun. So, compute lang yan. Ang I natin ay 32.74 degrees. Or in degrees, minutes, seconds, we have 32 degrees, 44 minutes, 22.32 seconds. Okay. Now, we can find the length of curve, which is pi ri over 180 degrees. So pi ri over 180, we have pi r is 213.6 times I. Kunin natin yung degrees, minutes, seconds para sakto. Over 180 degrees. So the length of curve is 120.054 meters. Okay. So the stationing of PT, ito yung solution. Let's copy that here. The stationing of PT is equals to stationing of PC, which is equivalent to 9 plus 346.1 meters plus 122.054 meters. So in adding stationing class, again, ang 9 plus 346.1 means that the station is 9 kilometers and 9 kilometers and 346.1 meters. So kung itatype natin sa calculator, it is 9,346.1. Then add 122.054. So when you add that, equivalent stationing is 9 plus 468.154 meters. So that's the stationing of PT. Okay? So yan ang stationing ng PT. And yun na. Yun na yung sagot. Any question, class? Simple curve. May tanong sa simple curve?
Wala po.
Okay, wala. Let's proceed to compound curve. So when it comes to compound curve, this is just two adjacent simple curve. So magkatabing simple curve na parehas yung direksyon ng kanilang liko. So for example, galing ka sa PC, going PT. So you are going to the right. So pupunta ka sa right dun sa unang curve at pupunta ka ulit sa right sa pangalawang curve. So parang ide-diretso lang. Pero kung ikaw yung driver, mafe-feel mo yung sudden change in sharpness of the curve due to the design of the roadway, which is a compound curve, which has two different radius of the simple curve, of the compound curve rather. So dito lang naman, may mga additional parts lang naman tayo. All we need to do is extend that tangent here and the tangent of the second curve para maka-form ka ng panibagong point of intersection. So, syempre, yung angle of intersection ng dalawang tangents, meron din I. So, originally, ito yung angle of intersection ng separate simple curves. But, ngayon na compound curve na sila, na-combine sila, ito na ngayon yung kanyang angle of intersection. So, determine the angle of intersection, just add the two central angle o yung angle of intersection ng dalawang simple curve. So, I1 plus I2. Now, may tinatawag din tayong common tangent or simply yung dalawang tangent na magkatabi ng dalawang curve. So, makaka-form yun ng straight line. So, call that the common tangent. So this is the common tangent, this one. Okay, this is the common tangent. Another, we have the long chord. Long chord is a line measured from PC to PT. So ito yung long chord. So may mga iba pa tayong parts such as itong x, distance x, yung distance galing sa vertex. So initially ito yung point of intersection, di ba? Para sa simple curve kung mag-isa lang siya. But since compound curve na siya, we use vertex as the term for that point. Para di tayo malito kung alin na yung point of intersection. So, yung distance galing sa vertex to point of intersection, yun yung x. So, ito, essential lang naman to sa paghahanap ng stationing stationing ng compound curve. So, later, kapag magsasagot tayo ng problem, so we will determine this x here. So, ito naman, long chord. Madidetermine natin siya by considering this triangle form by the chords of each simple curve. So ito yung chord ng una, ito yung chord ng pangalawa. So, ang tawag naman natin dun sa point kung saan nag-connect yung dalawang simple curve is the point of compound curve or the PCC. Now the rest lang din naman, may PC tayo, may PT, tangent ng each curve, tangent nito, and yun na. So to determine pala the common tangent, just add the tangent of each curve. Kasi ito, parehas lang naman yan dito. Itong T2, parehas dito. So, kung pinagtabi lang naman yung dalawang tangent ng dalawa, so mahanap na natin yung common tangent. Next. Find the stationing of PCC and PT. So yun na, sa paghanap ng stationing, kung given yung PC at hahanapin natin yung itong stationing nitong PCC. Kung given ang stationing ng PC, hanapin lang natin yung length of curve. Okay? And just add it to the stationing ng PC. So yung length of curve ng unang curve will be added on PC. But what if yung given is yung stationing ng PI? So syempre kasi at initial survey, ang mga given lang naman talaga dyan ay yung mga traverse at yung stationing ng mga point of intersection. So kung may point of intersection na tayo at mag-i-introduce ka na ng curve, edi yung pathway na to, hindi na to yung talagang roadway. Itong straight line from the PC to PI. So hindi siya roadway. So, ang kailangan nating stationing ay galing sa PC papunta dun sa PT. So kung ang given na stationing ay PI, kailangan nating pabalikin yung stationing na meron dito papunta dun sa stationing ng PC. That's why we need to subtract this x and the tangent 1. So isusubtract natin yun dyan. Then, tsaka tayo mag-a-add ng length of curve. Because ito na yung talagang dapat na stationing na i-determine na dapat hanapin sa paghahanap ng stationing ng PCC. Same way kung PT, yung stationing na pinapahanap. Kung galing sa PC, just add LC1 and the length of curve of the second. Ganun din kung stationing ng PI, ang given, subtract X, subtract T1, then add LC1 and LC2. Okay. So, halos yung ibang formula dito, dun sa galing sa simple curve ay mag-a-apply pa rin dito sa compound curve. Meron lang tayong mga additional solutions na gagamitin, pero more on ano na lang to, trigonometry ang solution natin dito. So, let's start answering this problem. Okay? Compound curve laid on the tangents have the following data. I1 31 degrees, I2 36 degrees, T1 3 degrees, T2 4 degrees. So wala yung drawing na kasama, class. Talagang worded problem. So tayo magdodrawing yan mismo. So given na yung mga degree of curve and given din yung stationing ng PI, hanapin daw natin yung common tangent, long chord, length of first curve, length of second curve, total length of curve, and the stationing of PT. So given yung degree of curve, hanapin muna natin, class, yung radius ng kada curve. So sinabi doon, use arc basis. Okay, use arc basis. Using arc basis, para sa radius 1, so kanina dinerive natin degree of curve 1145.916 over r. So simultaneously, or pwede din naman hanapin natin yung r in terms of the degree of curve. So 1,145.916 over t. So yan ang solution para sa radius ng una. Kaya 1145.916 over 3 degrees. The first radius is 381.972 meters. R2 is 1145.916 over D equals to 1145.916 over 4. Kasi yung D2 natin is 4 degrees. So the second radius is 286.479 meters. So base sa nahanap nating radius, mas mahaba yung first curve kasi yung radius niya 381.972 compared to the radius 2. So from that, we can draw the figure. So dito kasi may sample drawing na ako. But kunyari kung wala kang drawing pa, try natin i-drawing. So, ano lang yung gagawin? I-drawing nyo yung mga radius ng simple curve natin. Let's say yan. And yan. Then, yung pangalawang curve naman, mas maikli. So, i-connect mo lang siya along the line dito sa ating first curve. So, yan. So, yan, red. Then, tsaka kayo mag-drawing ng curve. Say, green. Yan. So, yan. Pwede na yan. So, ito yung PC, PT. Then, drawing na natin yung mga tangents. Okay, tangent yan. Tapos, tangent din dito. Yun. Yun na yung angle of intersection. Tapos, patungan nyo ng common tangent. So, yan. Adjust na lang natin. Yan, common tangent. Yun. Yan na. So, yan ang itsura nung ano natin. Tsaka nyo na ilagay yung mga na-determine natin na given, such as radius 1, radius 2, I1, I2, tapos yung I doon, pwede mo nang mahanap. So ito, I1 dito, kasi angle of intersection din siya, I2. So ganun lang, class, pag drawing, kung talagang walang given na drawing. So ito na. So ito na yung drawing. So ilagay niya lahat ng pwedeng ilagay na part nung compound curve para mas madali ma-visualize natin yung solution na dapat gawin. So unang tanong ay hanapin yung common tangent ng compound curve. So ang common tangent ay ito. Ito yung common tangent. Yan. So, paano hanapin ang common tangent? Ang common tangent ay sum of the tangents of the first curve and the second curve. Kaya, solve lang natin yung tangent nung una. Wala. Yan. Solve lang natin yung tangent nung una at nung pangalawang curve. So the common tangent is tangent 1 plus tangent 2. The tangent 1 is R1 tangent I1 over 2. Okay? Yung given, yung sinolve natin na radius 1, 381.972. Tangent I1 is, ano yung I1? 31. 31 degrees divided by 2. So, tangent 1 is 105.930 meters. How about the tangent 2? Tangent 2, so lagyan lang ng subscript na 2 para ma-identify natin na ito para to sa second curve. Okay? So, substitute. R2 is 286.479 tangent 36 over 2. So, tangent 2, 93 degrees, 93.083 meters. Yan. Pwede na mahanap si common tangent. Add lang yung dalawa. Okay. Common tangent is 199.013 meters. Okay. So, yun na. Sagutan na natin yung unang tanong. Common tangent. So, madali lang ang common tangent kasi kahit di mo gamitin yung figure, masasolve natin siya since meron tayong radius and angle of intersection ng kada curve. So, itong second question. Length of the long chord. Length of the long chord. So, saan yan dito? Ang length of long chord ay nandito. From PC to PT. That's the length of long chord. So, sa pagsosolve ng long chord, as I mentioned earlier, kukunin natin itong triangle na to. PC, PT, and PCC. So, we take this triangle. Okay. Para ma-solve natin yung long chord. So, kapag kinuha natin yun, ito na yun. Okay? Ito yung chord ng unang curve. Ito naman yung chord ng pangalawa. Ito yung long chord. So, lagyan natin ang marker from PC, PT, PCC. So, hanapin na natin yung chord ng kada curve. So, 2R sine I1 over 2 is equivalent to 2 times 381.972 sine 31 degrees divided by 2. The length of the first chord is 204.155 meters. The length of the second chord is 2 to R1 to R2 sine I2 over 2, which is 286.479 sine 36 degrees over 2. So L2 is 177.054 meters. Okay. So we have L1, L2. Check na. So in order to determine the length of long chord, we can use law of cosines. So using law of cosines, kung ito yung unknown, kailangan natin yung value ng opposite angle niya, which is itong beta. So, paano mahanap itong beta? Now, going back here sa ating compound curve. So, yung equivalent deflection angle natin from the tangent to the chord is 1/2 the central angle. Kaya I over 2. Same din dito sa kabila. 1/2 nung central angle niya, yun yung equivalent angle from the tangent to the long chord or to the chord ng second curve. Kaya, kung i-add natin ito, kasi along the, common tangent, which is a straight line. So when we add the three angles, which is I1 over 2, beta, and I2 over 2, that is equals to 180 degrees. Okay? Kung meron na din naman tayong I1 and I2, madali na lang hanapin itong beta by solving 180 degrees minus I1 over 2 minus I2 over 2. So, solve na natin, class. Beta, 180 degrees, I1 over 2 minus I2 over 2. So, 180 degrees minus 31 degrees over 2 minus 36 degrees over 2. Beta is 146.5 degrees. Okay. So, kompleto na. Meron na tayo beta. So, pwede na natin i-apply ang law of cosines. Using law of cosines, so, yung side natin is L. So, L squared equals to L1 squared plus L2 squared minus 2L1 L2 cosine beta. So, law of cosines lang. So, substitute na natin yung lahat na na-compute natin kanina. Then, take natin yung square root of both sides para ma-eliminate yung exponent na 2. So, the square root of L1 is 204.155 square plus 177.054 square minus 2 times 204.155 times 177.054 cosine of angle beta 146.5 degrees. Okay. Compute na yan sa calculator. Sagot ay 365.118 meters. So, yun na ang length of long chord. Okay? So, magfo-focus ka lang sa triangle PC, PCC, and PD. Next question. What is the length of the first curve? The length of the first curve, length of arc. So, substitute lang natin yung mga given. So, medyo madali lang. 381.972, 31 degrees over 180. So, LC1 is 206.667 meters. The length of the second curve, ganun lang ulit, by R2 is 286.479 times 36 degrees over 180 degrees. So LC2 is 180 meters. Okay. 180 meters. That's the answer for letter D. For letter E, hanapin yung total length ng curve. Total length, just add the two. LC1, LC2. So yun, nahanap natin kanina, add lang. 206.667 plus 180. So the total length of curve is 386.667 meters. Okay. Yan yung sagot, class. Last question sa problem na to ay hanapin daw yung stationing ng PT. So, balik tayo. Stationing ng PT. Kung babalik tayo dito sa given yung stationing ng PI. So, kailangan natin i-subtract yung X, subtract yung T1, then add the LC1, and add LC2. So, yun nga sa formula natin kanina, kung given daw yung stationing ng PI, ito yung equivalent o ito yung corresponding solution determining the stationing of PT. So, isa sa problema natin dito yung X kasi wala pang value yung X. So, babalik tayo dito sa compound curve, ang X ay ito. Ito yung X from PI vertex. So, para ma-compute yung X, dito tayo magfo-focus sa triangle na to. Sa vertex 1, vertex 2, and PI. So, focus dyan sa triangle na yan. Ito na yan. Okay? So, ito yung point of intersection. Ito yung vertex 1, vertex 2. So, ito naman yung angle of intersection which is 31 plus 36 degrees which is equals to 67. Tama ba? 67 degrees. So, ang equivalent, yung supplementary angle niya, 180 minus 67 is 130 degrees. Ito naman yun, equivalent nitong angle na to. Let's say theta. So, yung common tangent na hanap na natin, yan yung distance galing sa vertex 1 and vertex 2. So, halos kompleto na naman na yung given dito. Meron ka ng distance nung length dito sa side na to, angle dyan. So, lahat ng interior angles dito sa triangle na to, halos given. All we need to do is apply law of sine. So, x over sine of I2 is equals to, gamitin natin yung common tangent, over sine of 113 degrees. Okay. So, cross multiply natin to doon para matira yung x. CT sine I2 over sine 130 degrees. So, yung CT natin, 199.013 times sine I2, 36 degrees over sine of 113 degrees. So, x is 127.079 meters. Yun. May x na. Okay. Balik tayo dito. Stationing ng PT. Rewrite ko lang. Station ng PT equals to station PI minus x minus T1 plus LC1 plus LC2. So, substitute na natin. Stationing ng PI 8 plus 750 minus x 127.079 minus T1, na-compute natin kanina, 105.930 plus LC1, 206.667 plus LC2, 180. So, the stationing of PT is station 8 plus 903.658 meters. So, that's your answer for stationing of PT. Okay? So yun na yung sagot sa lahat ng tanong dito sa problem na to. Medyo mahaba lang yung solution. But lahat ng application lang naman na ginamit natin dito dun sa mga additional solution is just plain trigonometry. So the rest, nakabase na sa formula dun sa simple curve. Okay? Next problem for compound curve. Given the tangents of a compound curve intersect at an angle of 104 degrees. So yung I yun. The first curve has a radius of 420 meters. So R1, 420. The central angle of the first curve is 38 degrees. So I1. If the common tangent is 200 meters long, CT, 200 meters, what is the radius of the second curve? So ito, given na yung yung angle of intersection. So, di ba? Angle of intersection is just the sum of angle of intersection nung kada curve o yung central angle nung kada curve, nung dalawang curve. Kaya kung given yung angle of intersection ng compound curve, which is 104 degrees, I1 is 38 degrees plus I2. We can determine I2. I2 therefore is 104 degrees minus 38 degrees. So I2 is 66 degrees. So magagamit natin yan later on because pinapahanap yung radius ng pangalawa. So we know that the common tangent is the sum of the two tangents. So kung meron tayong common tangent na given, which is 200 meters, tangent 1, pwede natin siyang mahanap kasi meron tayong radius and I1. So hanapin na natin. Formula is R1 tangent I1 over 2. So the tangent 1 is R1 is 420. Tangent of I1 is 38 over 2. So tangent 1 is 144.618 meters. So, balik tayo dito. Common tangent, substitute na natin, which is 200. Substitute na rin natin yung tangent 1, 144.618 plus t2. Pwede na natin mahanap yung tangent 2. So tangent 2 therefore is 200 minus 144.618. So subtract the 2, we have 55.382 meters. So from tangent 2, doon na natin madiderive o makukuha yung radius ng pangalawang curve kasi T2 is R2 tangent I2 over 2. So ito yung required. So divide both sides by tangent I2 over 2. That's the second radius. Substitute na natin. Tangent 2, 55.382 over tangent 66 over 2 to R2. Compute 85.281 meters. So ganun lang. No figure needed for this problem. Any questions sa compound curve? Class?
Wala po, sir.
Okay, wala. Let's proceed.
Sir, ang bilis.
Mabilis. Okay. Nire-record ko naman tong presentation. So, sana ma-save. At isend ko mamaya yung recording. Okay? So, nakita na sa screen class yung PowerPoint for the reverse curve. Please confirm. Okay. So, for the reverse curve, halos similar din sa compound curve kasi it requires two simple curve. Only that it has different direction. Okay? Kung papunta sa right yung unang curve, yung isa papunta sa left yung direction ng second curve. So, halos lahat naman parehas. May PC, may PT, vertex 1, vertex 2. Wala lang tong point of intersection. But the point where the two curves connect is what you call the PRC, or the point of reverse curve. So, finding the station of PRC. So, kung given yung stationing ng PC, same solution dun sa compound curve, add LC1. Kung given yung stationing ng vertex 1, isubtract mo yung T1, itong T1, then add LC1 and LC2 kung hanggang PT. Kung PT yung pinapahanap. So, ganun lang ulit, class. Subtract T1 kung galing sa vertex 1. Okay? So, there are two types of reverse curve. Una, yung non-parallel, yung tangents. So, if the back tangent is this one, so hindi siya in line with the forward tangent. The second type is the reverse curve with parallel tangents. So, ito yung parallel tangents natin. Yung back tangent and forward tangent, parallel sila. So, may parallel distance yan. And sa reverse curve na merong parallel tangents ay laging parehas yung kanilang angle of intersection. Okay? So, parehas lang ang angle of intersection sa reverse curve with parallel tangents. So, ang pagdating sa radius, pwede magkaparehas din, pero pwedeng hindi din. Pwedeng hindi. So, dito, laging parehas ang angle of intersection. So, let's start answering sample problem. Ayan. Again, wala din tong drawing. So, we are the one that will draw the figure for this particular problem. Sabi dito, two parallel tangents. So, ito yung clue. Two parallel tangents, which is 10 meters apart, are connected by a reversed curve. The chord length from PC to PT is 120 meters. So, ang chord length, PC to PT, 120 meters. Determine the common tangent, the equal radius of the reverse curve. So, dyan pa lang, clue na yan, na ibig sabihin, the radius of the first curve is equal to the radius of the second curve. Then, letter C, compute the stationing of PRC if the stationing of PC is 3 plus 420 meters. Okay. So, let's say wala tong drawing na to. Ignore natin yan. Paano natin i-drawing yung parallel tangents na reverse curve and equal radius? So, let's try to draw. So, wala naman sinabi na direction ng azimuth ng mga tangent. So, tayong bahala paano yung orientation nung reverse curve. So, una natin gawin, mag-drawing tayo nung unang radius. Say ito, radius niya. Tapos, yung radius nung pangalawa, i-copy natin since parehas to. I-copy ko siya. Like this. So, ito yung dalawang radius. Ito yung radius ng pangalawa. So, syempre may equivalent tangent siya dito. Diba? Equivalent tangent siya. So, adjust natin to. Yan. So, sinabi doon, mayroon siyang given na parallel distance na 10 meters. Okay? So, sa pagdodrawing ng reverse curve, So, kung meron tayong tangents, dapat meron ding common tangent. So, i-connect natin yung dalawa. Say, dito. Papunta dun. Yun. Then, i-connect natin yung dalawang dulo ng radius. Yun. Yun na yung midpoint. O, dun na yung PRC natin. PRC. Then, tsaka natin i-drawing yung curve. So, ito yung PC. Papunta doon. Then, papunta naman doon. Doon yung PT. So, ito, tangent 2, tangent 2, tangent 1, tangent 1. Ito-draw nyo naman yung chord. Draw lang a line from PC to PT. So, color blue. So, ganun lang, class. Equal radius. Ganun lang pag-drawing ng reverse curve. So, unahin nyo yung radius, tigdulo. Kung parallel, i-extend nyo yung dalawang tangent. Then, take the dimension of that. Tapos, draw another line, which is itong color red, which serves as the common tangent of the two lines. Then, draw the curve, itong color green. Then, connect the PC to PT with a line, which is the chord. Okay? So, let's say ito na yun. Ito na yun yung drawing natin. Okay. Since parehas yung radius niya at parehas yung and sa parallel tangents, parehas lang din naman ang angle of intersection. Ibig sabihin, symmetrical ang, almost symmetrical yung mako-form natin. Similar yung simple curves na mabubuo natin dun sa una at pangalawa. So, ibig sabihin, ito parehas, kaya lang baliktaran lang dun sa pangalawa. So, yun. Parang naka-mirror lang. So, pinapahanap yung common tangent. So, kung lalagyan na natin nga ng mga common tangent and length of chord, yung length of chord natin ay given, which is 120 degrees. So, ito na yung itsura ng dalawang simple curve. Ito yung unang simple curve. Ito naman yung pangalawang simple curve. So, parehas lang naman sila ng size. So, ibig sabihin, kung susukatin natin itong distance na to from the center to this point, o yung extended distance, extended dimension natin galing sa PC, kalahati iyan ng 10, which is 5. Okay. So, exclusive lang naman siya, itong solution dito, para sa parehas na radius. So, kung ito yung common tangent mo, yun yung unang required, hindi pa natin siya mahahanap kung wala pa tayong angle of intersection, which is I. Saan natin pwedeng kunin na itong I na to? So, ang value na lang na may given tayo dito ay itong length of long chord from PC to PT, which is 120 meters, and the parallel distance of tangents. Itong line na to. So, galing dyan, makaka-form tayo ng right triangle kapag kinuha natin tong triangle na to. Yung long chord, itong distance nung parallel distance, and itong line, horizontal line na to. So, kung natin yan, ito na yun. So, we have 120 meters, 10 meters, and I over 2. Ang I over 2 kasi, di ba siya yung angle measured from the tangent and the chord of the first curve. Kaya, kalahati siya nung central angle natin, which is I. So, doon yun galing. Now, just apply sine function. So, sine I over 2 equals to 10 over hypotenuse 120. So, I over 2, take the arc sine of 10 over 120. then multiply it by 2. 10 over 120. So I is what? 9.560 degrees, or in degrees, minutes, seconds, 9 degrees, 33 minutes, and 37.38 seconds. Okay. For the common tangent, we have here sine I equals to, yung common tangent pala, itong triangle na to, makukuha natin yan dito. Ito yung common tangent, and yung distance na to, kukunin lang din ulit natin itong vertical distance na to, o yung parallel distance between tangents, and this line here, maka-form ulit tayo ng right triangle. Ito na yun. So, itong angle naman nito, yun din yung equivalent na angle of intersection ng unang curve. So, 10 over the common tangent, CT. So, I equals to arc sine of 10 over CT. Ay, CT pala yung Okay. Cross multiply natin. Yan, ito, multiply mo dyan. CT 10 over sine of I. CT equals to 10 over sine 9 degrees, 33 minutes, and 37.38 seconds. So this is CT 60.209 meters. Okay. That's a common tangent. Ano pa yung isang required? Equal radius of the reverse curve. So what is the equal radius of the reverse curve? Since we already have the common tangent at parehas lang naman class yung kanilang radius, so ibig sabihin, kung parehas yung radius niya at parehas yung kanilang angle of intersection, edi yung kanilang tangents ay the same. So therefore, their common tangent is just T1 plus T2. Or since T1 is equals to T2, just divide CT by 2 in order for us to determine the tangent of a single curve. Kaya, for the common radius, just divide the common tangent that is determined earlier by 2. So yung 60.209 meters divided by 2 is equals to 30.105. So this is the tangent, 105 meters. From that, we can determine the radius of the curve since we already have the angle of intersection. So tangent is equals to R tangent I over 2. So required is R. So divide both sides by tangent I over 2 equals to R. Substitute na natin 30.105 over tangent 9 degrees, 33 minutes, 37.38 seconds. Be divided by 2 is equals to R. So R is equals to 360.003 meters. That's your answer for the radius or the equal radius. So parehas lang naman. Letter C, compute the stationing of PRC kung ito yung stationing ng PC, 3 plus 4, 20 meters. So given lang naman dito ay stationing na nung PC. So all we need to do is just add the length of curve. So for letter C, determine first the length of curve of the first curve kasi PRC yung pinapahanap na stationing. So pi Ri1 R1 over 180 degrees. So I have pi 360.003 times 9 degrees, 33 minutes, and 37.38 seconds to be divided by 180 degrees. LC1 is 60.070 meters. Then compute the stationing of PRC. So station of 3 plus 420 meters plus 60.070 meters. So add natin stationing ng PRC is station 3 plus 480.07 meters. So this is your answer here.